Question 1. The speed of a wave on a particular string is 24 meter per second. If the string is 6.0 meter long, to what driving frequencies will it resonate? Option B is correct. 2 Hz, 4 Hz and 6 Hz. Question 2. The apparent change in the frequency of a sound caused by the relative motion of either the source of sound or listener or both is called Doppler effect. Option D is correct. Question 3. Which one of the following is not a characteristic of stationary waves? Option D. Energy of the stationary waves travels outward. And vibrating chord, the point where the particles are stationary is called? Option A. Node. Next question. If the wavelength of a transverse wave is 2 cm and the period is 2 seconds, then the wave speed in GGS is option D. 1 cm per second. Orange light in a vacuum has a wavelength of 600 nanometer. What is the frequency of the light? Option D. 5 multiplied by 10 power 14 Hz. An electromagnetic wave travels in a straight line through a vacuum. The wave has a frequency of 6 Hz, T-Hz. What is the number of wavelengths in a distance of 1 meter along the wave? Option C. 2.0 multiplied by 10 raised power 4. In a stationary wave, the distance between consecutive antinodes is 24 cm. If the wave velocity is 300 meter per second, then the frequency of the wave will be option C. 600 Hz. Question 9. When a ray of light enters a glass lit palm ear, option A. Its wavelength decreases. Question 10. What is the relationship between the intensity I and the amplitude A of the wave? Option D. Intensity by amplitude square constant. In a vibrating chord, the point where the particles are stationary is called node. Option C is correct. Question 12. The sound waves and light waves cannot be both polarized. Option A is correct. If a wave can be polarized, it must be option C, a transverse wave. Sound waves cannot be polarized. Option A is correct. The transverse nature of light is verified with the phenomena of polarization. Option B is correct. The intensity of a wave is directly proportional to amplitude square. The frequency of a light having wavelength 10 multiplied by 10 raised power minus 3 cm is option C. 1 multiplied by 10 raised power 10. Question 18. A sound wave has a speed of 330 meter per second and a frequency of 50 Hz. What is a possible distance between 2 points on the wave? They have a phase difference of 60 degrees. Option B is correct, 1.1 m. Question 19. If the amplitude of a wave at a distance r from a point source is A, then amplitude at a distance 2r will be option B, A. Next question. Electromagnetic waves are produced by oscillating charges. Sound waves are produced by oscillating tuning forks. How are these waves similar? Option C. They both have the same frequency as their respective sources. Two progressive waves of frequency 300 Hz are superimposed to produce a stationary wave in which adjacent nodes are 1.5 meter apart. What is the speed of the progressive wave? Option C. 450 meter per second. Question 22. Sound waves of frequency 100 Hz are transmitted in a cylindrical tube that is closed at one end. The stationary waves formed in the tube produced adjacent nodes that are 1.5 meter apart. What is the speed of sound waves? Option C. 320 meter per second. Longitudinal waves cannot be polarized. Option B is correct. The wavelength of a wave traveling with speed and having frequency f is option C, lambda is equal to V by f. Question 25. The speed of a sound in air at NTP is 300 meter per second. If the air pressure becomes 4 times, then the speed of the sound will be option B, 300 meter per second. 26. Laplace corrected Newton's formula for the velocity of sound in gases because the sound propagates adiabatically. Option B is correct. When the light enters from air to glass, it suffers a change in option D, wavelength and speed of light is correct. Question 28. The speed of a sound in air is 334 meter per second at a pressure P. What will be the speed of a sound if the pressure becomes 4 times? Option B is correct, 334 meter per second. If temperature of medium increased by 1 degree centigrade, then speed of a sound will rise. Option C, 61 centimeter per second. Question 30. The phase change of 180 degree is equivalent to a phase difference of option A, lambda by 2. Question 31. What is the optimum difference in phase of maximum destructive interference between two waves of the same frequency? Option A is correct, 180 degree. Question 32. Mark out the correct option. Option B is correct. The energy of any small part of a string remain constant in a standing wave. And stationary waves, option D is correct, both A and B. Which one of the following is not characteristic of a stationary wave? Option D, phase is the same between two adjacent nodes. In a stationary wave, the distance between a node and next antinode is equal to option D, lambda by 4. Question 36. Standing waves are produced in 10 meter long stretched string. If the string vibrates in 5 segments and wave velocity is 20 meter per second, its frequency is option C, 5 Hz. The number of loops in the standing waves is directly depends on option B, frequency. A stationary sound wave has a series of nodes. The distance between the first and sixth node is 30 centimeter. What is the wavelength of the sound wave? Option D, 12.0 centimeter. A sound wave has a frequency of 2500 Hz and a speed of 1500 meter per second. What is the shortest distance from a point of max pressure in the wave to a point of minimum pressure? Option A is correct, 0.15 meter. Question 40. An organ pipe is open at both ends at its fundamental frequency, neglecting any end effect. What wavelength is formed by this pipe in this mode of vibration if the pipe is 2 meter long? Option B, 4 meter. An organ pipe of length has one end closed but the other end open. What is the wavelength of the fundamental node emitted? Option B, slightly larger than 4L. A 3 meter long string resonates in 3 loops. The frequency of stationary wave having velocity of 30 meter per second is option C, 15 Hz. Question 43. A source of a sound of a frequency 5 Hz is moving towards an observer with velocity 30 meter per second. The speed of a sound is 330 meter per second. The frequency heard by the observer is option A, 550 Hz. Question 44. Which one of the following properties of light does not change with the nature of medium? Option A, frequency of light. Water waves in the sea are observed to have a wavelength of 300 meters and a frequency of 0.07 Hz. The speed of these waves is option C, 21 meter per second. Two identical but separate strings with the same tension carry sinusoidal waves with the same frequency. with the same frequency. Wave A has amplitude that is twice that of wave B and transmits energy at a rate that is that of wave B. Option D, 4 times. Question 47. The dimension of amplitude of a wave are. Option B. Question 48. The earthquake is in nature. Option A, mechanical. Question 49. A sound wave enters from air to water. Its wavelength increase. Option A is correct. Transverse waves do not propagate through gases because gases have no bulk modulus. Option B is correct. The dimension of intensity of a wave are. Option C is correct. Electromagnetic waves are in nature transverse. Option A is correct. The wavelength of a sound in air is 10 cm. Its frequency is. Option B is correct, 3.3 kilocycle per second. Question 54. The velocity of a sound is maximum in water. Option A is correct. Question 55. If the tension in the string is double and its mass per unit length is reduced to half, then the speed of transverse wave on it is double. Option A is correct. Two sound waves having a phase difference of 60 degrees have path difference of. Option C, 1 over 6. Transverse waves cannot be generated in gases due to less elasticity. The intensity of a wave is. Option D, directly proportional to r square. Question 59. The increase in speed of a sound when temperature is increased by 1 degree centigrade is. Option D, 0.61 centimeter per second. The speed of transverse waves in a string is v. If tension is quadrupled, then speed of transverse waves will be. Option A, 2v. 61. Sound waves cannot be polarized. Option C is correct. If the period of the wave motion is 4 seconds and speed of wave is 40 meter per second, then frequency is. Option B, 0.25 Hz. Question 36. If the tension in a stretched string is made 4 times the speed of a wave along the string is increased 2 times. A closed-end pipe of 4 foot long resonates to a given tuning fork, then wavelength is. Option C, 16. Question 65. Frequency of a sonometer in terms of mass per unit length of the string varies as. Option C is correct. Question 66. Transverse waves can propagate. Option B. Next question. Which of the following phenomena cannot take place with sound wave? Option D is polarization. Question 68. Which of the following properties of sound is affected by change in air temperature? Option A, wavelength by speed. Keeping temperature constant. If the pressure is increased, the speed of a sound in a gas. Option C remains unaffected. Question 70. Which of the following statement is wrong? Option D, sound travels faster in vacuum than in air. Question 71. Which one of the following factors have no effect on the speed of a sound in a gas? Option B, pressure. Question 72. Superposition of a number of harmonic waveforms. Option C, complex waves. Question 73. In order to hear the echo of a sound, the minimum distance between listener and the obstacle must be. Option B, about 17 meter. Question 74. Reverberation time of a hall can be decreased by. Option C, choosing a smaller hall. Question 75. The wall of the hall built for music concerts should. Option C, absorb sound. Question 76. When a transverse wave is reflected from the boundary of a denser to rarer medium, it undergoes a phase change of. Option C, pi. Question 77. When a stationary wave is formed, then its frequency is. Option A, same as that of the individual waves. Next Energy is not carried by option D, stationary waves. Question 79. The sonometer wire is vibrating in the second overtone. We may say that there are option C 4 nodes and 3 empty nodes. Question 80. The wavelength of the fundamental mode of vibration of a closed beam pipe is option C 4L. Question 81. A closed organ pipe 1 meter long resounds in its fundamental mode of frequency of 100 Hz. The velocity of a sound will be option C is correct, 400 meter per second. Question 82. The ratio of the fundamental frequency of an organ pipe and closed organ pipe of length is option A 2:1. Question 83. The distance between two successive nodes is option B lambda by 2 is correct. Question 84. In standing waves, option C energy is minimum at nodes and maximum at antinodes. Question 85. If a string is set to vibrate in 10 loops, then the frequency of a wave along it, option D 10 if not. Question 86. An organ pipe open at both ends contain option A longitudinal stationary waves. Question 87. The unit of intensity of a sound is option A watt per meter square. Question 88. A vessel giving out 450 Hz approaches a stationary observer at a speed of 33 meter per second. The frequency heard by the observer in Hz is option A is correct, 499.5. Question 89. When a source is going away from a stationary observer with a velocity equal to that of sound in ear, then the frequency heard by the observer will be option B half. Question 90. Doppler effect is applicable for option D both A and B sound waves, light waves.